All right, let's talk about one of the most important, kind of secret weapon algorithms that powers the internet you use every day: consistent hashing. It's the invisible magic that lets massive systems like Netflix, Amazon, and Redis get bigger and bigger without just falling apart. So let's get into it. So, picture this. You're running a huge service, you've got a whole bunch of servers, and things are running smoothly. Then, poof, one server goes offline. It's just one, right? Should be a tiny blip. But instead, your entire system just implodes. Everything grinds to a halt, databases get slammed, and your users are seeing nothing but error messages. How is that even possible? Well, the scale of the chaos is just staggering. In a tiny system with only 5 servers, losing just one of them forces about 80% of your data to find a new home. 80%. Think about that. That means nearly all your user sessions, your cache data, your product information, it all gets thrown into a blender. It's basically a self-inflicted catastrophe. So, let's dig into why this happens. This isn't just some weird bug. It's a deep, fundamental flaw in the most basic way people think about distributing data across servers. And the culprit is this deceptively simple little formula. You take a key, you hash it, and then you use the modulo operator with n, where n is your total number of servers. See the problem? The location of every single key is directly tied to n. So the moment n changes, if a server is added or if one dies, the answer to that equation changes for almost every single key in your entire system. It's a house of cards. So how do we get out of this mod n trap? There has to be a better way, right? Well, there is. And it's this incredibly clever and elegant idea called consistent hashing, which completely flips the script on how we map data to machines. Let's see how it works. You see, at its heart, consistent hashing decouples your data from the raw count of servers. Instead, it imagines both the servers and the data keys being placed on a big, abstract circle, a hash ring. And here's the absolute killer feature. When a server joins or leaves, the number of keys that have to move is absolutely minimized. We're talking a tiny fraction, not the whole shebang. Okay, so how does this ring thing actually work? It's beautifully simple. First, you take your servers, their IP addresses or whatever, and you hash them to find their spots on the circle. Then, when you want to store a piece of data, you hash its key to find its spot on the circle. And to find out which server owns that data, you just start at the data's position and walk clockwise until you hit a server. Boom, that's the owner. That's it. And this is where you really see the magic. On the left, with the old way, adding a server is pure chaos, a total reshuffle. But on the right, with consistent hashing, look how calm it is. You drop a new server onto the ring, and it just calmly takes responsibility for the keys right before it. The vast majority of your other data doesn't even notice. Your caches stay warm, and the system just keeps on humming. Now, consistent hashing is a brilliant solution, but it's not quite perfect out of the box. There's one potential problem. If you're a bit unlucky with your hashes, your servers might not spread out evenly on the ring. They could all clump together, creating some real imbalances. Exactly. What happens then? Well, if they cluster up, you could end up with one server being responsible for a huge chunk of the ring. It becomes a hotspot, while another server is basically doing nothing. And even worse, if that overworked server fails, it dumps its entire massive load onto a single neighbor, which then probably fails, creating a terrible domino effect. And the fix for this is another clever trick called virtual nodes, or vNodes. The idea is, instead of placing each physical server on the ring just once, what if we gave it, say, 100 different positions? Now, if a server goes down, its 100 little jobs get spread out evenly across all the other physical servers in the cluster, not just dumped onto one poor, unsuspecting neighbor. And the benefits here are just huge. vNodes practically guarantee that your workload is spread out evenly. Failures become graceful little events that the system just absorbs. And here's something really cool. It lets you mix and match hardware. Got a super powerful server? Just give it more virtual nodes, and it will naturally, automatically take on a bigger piece of the pie. And I want to be clear, this isn't just some academic idea. This is exactly how the pros do it. Real-world systems like Cassandra and Amazon's DynamoDB often run somewhere between 100 and 200 virtual nodes for every single physical machine they have. It's a core part of their design. So now that we've got the theory down, where do you actually see this thing in the wild? Well, turns out it's pretty much the hidden backbone of the modern internet. Seriously, from the giant databases that store your data, like DynamoDB and Cassandra, to the lightning-fast caches like Redis that make your apps feel snappy.
and even the content delivery networks that stream you videos and images. They all depend on consistent hashing to work at scale.
Okay, let's make this real. Here's a common design problem. You just bought a brand new beefy server. It's got 3 times the power of all your other machines. So how do you make sure it actually does 3 times the work without having to rewrite a ton of complicated routing logic? And the answer with consistent hashing is just so clean. It's called weighted virtual nodes. You just assign that powerful machine 3 times as many vnodes as the others. That's it. The algorithm just handles the rest, automatically and proportionally sending it the right amount of traffic. It's beautiful. All right, one more challenge for you. You're building a URL shortener, something like Bitly. Speed is everything. And for this kind of service, speed means caching. How do you design a system that maximizes the chance you'll get a cache hit?
You probably guessed it. Consistent hashing is perfect for this. By hashing the short URL, you guarantee that every single request for that URL always lands on the exact same server. This creates something called cache locality. That one server gets to build a really warm cache for that popular link, giving you crazy fast performance.
Whew. Okay, we have covered a lot of ground here, from total system failure to this super resilient, elegant design. So let's just quickly boil it all down to the key takeaways you really need to remember.
So here are the big 4. First, that simple mod n approach is a ticking time bomb for any growing system. Second, the hash ring is our savior, placing everything on a circle to minimize disruption. Third, this means adding or removing servers only affects a tiny, manageable number of keys. And finally, virtual nodes are the pro move that perfects the system, ensuring the load is always spread evenly. And that really brings us to the final